All right, so today what we're going to do is we're going to finish up with strings by doing a few exercises here. These are the ones that I thought of on the way over here, so we'll go ahead and do as many of them as we can, and then with the remainder of our time, we'll go ahead and start on the next module, which is file I/O. Remember that we are online, so if you have any questions, you can post to Piazza, or you can go ahead and post to the YouTube live stream here. All right. So the first exercise that I wanted to do, I actually had written these up as a future exam, potential future exam. Obviously I'm not going to do that now because we're going to do them together here. But what I wanted to do is design a function to convert from a lower underscore casing convention, right? Many of you might have been using this convention for all of your variable names. And then we're going to convert that to a lower camel case convention, okay? And then we're going to do the opposite, right? Take a lower camel cased variable name as a string, and then produce a new string that is a lower underscore camel casing lower underscore casing convention. Okay. For this first one, let's go ahead and write our documentation for this. We're going to convert the given lower underscore case variable name to a lower camel case version of it, returning a new string. Right? For example, and you can put in, the documentation is the perfect place to put examples. For example, if I have number of students, right? Number of students will be converted to number of students. No underscores at all, but the first character of each word, right, which you can infer by looking at the underscores here, is going to be uppercase. All of the rest are going to be lowercase. Okay. So what should we call this first of all? Underscore to camel, right? And then we'll call the other one camel to underscore, right? We're going to take a string, right? And a string is going to be a char star s, right? That's the original, right? Are we going to be making changes to that old string? Probably not if we're producing a new string. So I'll go ahead and make that into a const, right? And then I will return a brand new string, which is going to be a char star, right? So do we understand what we're trying to do here? That if I were to give you number of students as input to this, I would expect number of students in this format back from it, right? So let's go ahead and set up our test down here. What I'm going to do is I'm going to go ahead and get rid of all this stuff that we had before. Actually, no. Let me go ahead and get rid of all of this stuff because we will want that as a test case later, right? I'm going to be doing some ad hoc testing here. Just going to make sure that it actually works on the example that we've already written, right? So result should be equal to underscore to camel, right? And we'll go ahead and give it number of students here, right? And then printf, the result is equal to %s and the line and result. So we should expect it to print out number of students all camel cased instead. Okay? So help me out. What's the first thing I should do? Make a copy? Okay. If I want to manipulate the original, sure. Right? Do I necessarily want to manipulate the original? I don't know. All right. Let's be really efficient. In other words, let's come up here and take a look at this. So number of students and number of students. How many characters are here versus how many characters are here? There are going to be more characters here than there are here, right? How many fewer characters are going to be over here? Number of underscores, right? So maybe as a first step, let's go through and count up the number of underscores. Okay. All right. Let's see. So int num underscores, right? And we'll start out at 0 here. Okay. So if I iterate over each character in the string for int I equals 0, I is less than S, size of s, is that correct? Nope. How do I get the size of a string or the length of a string? strlen. I++. Right? And if it's an underscore, if the ith character, if s of I is an underscore, just a literal underscore right here, right? Then we know that we found a new underscore, and so I'll say underscore plus plus. Okay? Okay. That tells me how much, how many characters were in the original, minus the number of underscore characters, tells me how big the new string should be. Let's go ahead and put that into a variable, n. Right? The new string should be of strlen of s minus the number of underscores, right? Plus 1, right? Yeah. I'll go ahead and put that when I actually allocate this, though. Char result, say, right, is equal to a call to malloc, char star malloc, size of char times n. Is that it for strings? Remember, HELLO, there's 5 characters there, but do I allocate just 5 characters? What else do I need? Always the null terminating character. Right? So let's put that into a +1 over here. Okay? Ultimately, I'm going to return result. Now let's actually build this string. Okay? I went through it once to count up exactly how many underscores there were so that I allocated just enough space. An alternative trick would have been to allocate something that is larger than the original, and then not have to worry about that extra space. Do my work, create it right as a temporary buffer like we did the other day, and then copy it over to a string exactly the size that I want. Right? But I'll go ahead and do it like this. Okay? All right, now what? Let's outline our code. For each character in S, right, what should I do? If it is an underscore, ... otherwise, else, if it's not an underscore, then just copy it over, right? But if it is an underscore, what do we do? Right? So I iterate through this string, this string, this string. Okay, great. Now I see an underscore. I don't copy it, but what do? I go to the next one and convert it to an uppercase character and then move on. Okay? So let's go ahead and write that. For int I equals 0, I is less than, what is it going to be? Could we go with strlen of the result? I++? Does that make any sense? Is the result built yet? Is it a valid string that I've null terminated yet? No. All right, so what should we do instead? strlen of the original string, s. Okay? So for each character in s, right? It's not for each character in result. There, I've done that. So if it's an underscore, I'll do something. So if s of I is an underscore, right? Did I do that? Yeah, I did it correctly up here. Right? Then we will do something else. I will go ahead and copy it over. Copy it over. ... Right? So results of I is equal to s of I. That's the easy case. There we go. So again, if it is an underscore, what do I want to do? Don't copy it, but then go on to the next one. So how can I go on to the next one without having to rely on the loop? I++, right? There's nothing saying that I can't go iterate once within at the end of the loop, but also I can iterate inside the loop, right? In fact, if this were a while loop, I would have to do that, right? So I see the underscore, I go immediately to the next one. And what do? I copy it, but uppercase it. ... So results of I is equal to s of I, but to uppercase. Right? That's not C code. how do I convert a character to uppercase? Do you remember? To tupper, right? Topper. Okay. Am I done after all of that? Nope. What did I not take care of at the very end? What goes at the end of every string? The null terminating character. Remember, strlen does not include the null terminating character. So if it was hello, right, then it's only going to go hello, and it's not going to include that null terminating character, and so I include it at the end. Is this going to compile? Come on. Oh, CS1 lecture. All right, let's find out. GCC wall flag demo.c. Right. Nope. I is undeclared. Also, data is unused, but we're eventually going to use that, so ignore that warning. I is undeclared. What did I do here? It's outside of the for loop, right? So maybe you have an argument here for going for old style C syntax here of creating the loop outside, or creating the variable outside the loop. Or what's an alternative? I simply want to set the last one, right? So hello, 0, 1, 2, 3, 4. Okay, so it would end up being 5. So maybe I could try something like this. strlen of result. Can I use a string library function on a string that is not necessarily a valid string yet? No. strlen would assume that it's already null terminated. That's how it counts, remember? Right? So we can't do that. So, did we store that off somewhere? N. Okay. There. Right. That's how many characters it is, right? So if it's 5 characters, 0, 1, 2, 3, 4, 5 is where you end up putting your null terminating character. Now let's see if that compiles. Right? Remember, those are just warnings. Oops, underscore 2 camel. Underscore 2 camel. Oh, did I not spell it correctly? Underscore 2 camel. Oh, I didn't spell it correctly somewhere. Maybe there. Okay, fine. All right, there. That's just a warning because I'm not using that data above. A dot out, it should, remember, I gave it number of students. It should print out number of students as all lowercase. Number. Okay. Is that correct? Nope. All right, back to the drawing board. So the first time that we see yeah, go ahead. Oh, no, any suggestion?
Wouldn't you need because in this, it's jumping to the next I, so isn't it, is it the size of the result, like, smaller? Technically.
I'm iterating over the original, and I'm going up by 1 to the next one. Mm-hmm. That should be, you're right, in that, at least I'm interpreting it as what you're saying here is something similar to what we did when we removed white space.
Yeah.
Right, what did we do, what was the problem there?
The original is bigger. So
We have I, so we use 2 index variables, right? I is for the original, and then we use j for the one because they were different sizes, right? So I should be doing the same thing here too, right? I shouldn't be using I all the time. I should be using j and establishing that, right? So int j is equal to, I'll start it out at 0. Right? Then what? If it's always 0, will that be good? No, what do I want? Increment it. And where do I increment it? Here, or here, or here.
in your else.
Okay, in my else. All right. J++. Okay. Is that the only time I copy something over, though? I'm also copying it here. So I could put it here and here, but if you're doing it in both the if and the else, Is there a way that I can cut down on code there? J++, right? Okay, I like that a lot better. Now do I need to put n in there? Probably not. I can just use j now because j will be incremented, but I'll go ahead and leave it like this. Let's see if it works. There we go. Hey, number of students. Right. One test does not mean that it absolutely works. Right. What else should I try? Okay, good question. Student or foo underscore bar. Okay. What do you think's going to happen? It's going to end up retaining one of those underscores is my guess. Right? Right. And then also missing out on that one R because we're not at the end. So we've got a lot of corner cases here probably to still do. I don't want to get into that though. Right? We'll assume that it is always of a correct form here. One other test that I do want to check to make sure that it works is foo, right? What should I expect back? Foo, right? The exact same thing. Why? Because no underscores, right? Maybe what if there's an underscore at the end? What if there's an underscore at the beginning? Ugh. Is that going to give us the result that we want? Nope. Now it's capital F foo. Right? So there are lots of corner cases here that we have to still deal with. Right? I'll leave that as an exercise to you though. Right? If you want to, you can name this simple underscore two camel casing. Right? Let's do the opposite though. Okay? And I'm simply going to cut and paste this. This is actually a reason why I ended up deciding to do it in class rather than give it on an exam or something, because as I was thinking about it, I was thinking there was too many corner cases. Begins with an underscore, multiple underscores, right? Ends with an underscore, things like that. So let's go ahead and go with a camel to underscore. Right. So it's just going to be the opposite here. Number of students to number of students. What is it going to look like? Right? It goes in the opposite direction here. Is it going to look much different than this at all? We're going to go through and instead of counting up the number of underscores, what are we going to do? Count up the number of capitals, right? And then that tells you how many underscores you should insert before a capital letter. Then you will convert the capital letter to an lowercase letter. Okay? Do we want to do it or not? Yes? No? Okay. Let's do it. And what did I call it again? It's just camel to underscore. All right, there we go. All I did was copy paste so that we can reuse a lot of the same code here. Num underscores, I'll go with num caps, right? Number of capital letters. You know what? That tells me maybe I should rethink this. Maybe I should put in a function to count characters based on some, you know, some criteria, right? If I give you a character and I gave you a string, I want to know how many of those characters appear in that string, underscore. Here in this case, it's not going to work as well because I want to know all caps, A through Z. So I don't want to have to call that function 27 times and count them all up, right? So I'll go ahead and do it manually here, but be thinking about that, right? Be thinking of where you see this code is similar, this code is similar, this code is similar. I could probably generalize that to one piece of code, put that into a function, reuse that function, okay? All right, so the number of caps. How do I tell if S of I is a capital letter or not? Well, to upper, right? There's another version called is upper, right? And remember that all of these things are in the C-type library, right? Is space, is upper, is lower, et cetera, right? Okay, there's my number of caps. How big will the new string be? It'll be as big as the old string, but now it'll be bigger, right? Because I need to insert those underscores right before that capital letter. So plus num caps. There we go. Same result as before. Right? And on this one, I don't know if I need J or not, but we'll go ahead and keep it. I think I do need J. Right? Now, if it's a capital letter, get rid of this, there we go, is upper, then what do I want to do? I want to insert an underscore. Right? So if it is an upper, then I'll insert an underscore, then insert a lowercase version of S of I. Okay? So, how do I do that? Results of, and I will here use J, is equal to an underscore. Right? And results of J plus 1 right next to it should be to lower of S of I. Okay? Otherwise, just copy it over. Right? Same thing as before. Okay. Do I do J++ in both of those cases anymore? In the if statement, I am copying 2 characters. In the else statement, I'm only copying 1. So I should account for that. If you're only copying 1, increment J by 1. If you're copying 2, increment J by 2. What's a more compact way of writing that? Plus equals 2. There we go. Yeah?
Wouldn't it also be fine to keep the J++ how it was, and then just add one more J++ in the if statement?
You could. You're trading 2 lines of code for two lines of code, right? And then clarity here and clarity here. You can argue about clarity, right? That's where you can get into. I think I told you what it was before, bike shedding, right? Arguing about the minutia at the expense of the overall stuff. Right? I told you about bike shedding, did I? Okay, all right. The color of the bike shed is important, right? What you paint the bike shed is important. Right? So let's go ahead and test this now in our main over here. So of course I will expect this to be number of students, right? And I'm calling camel to underscore. GCC, right? And run this, and I should expect the exact same result as I had before, number underscore of students, all lowercase. Yay, right? In fact, these are opposites of each other, right? If I take one input and feed it into the first function, and take that output and feed it into the second function, I should recover back the original, right? That suggests some really cool automated tests that you can do, right? All you have to do is test one, then test the other, and do you recover the original result? If so, then basically they both pass, right? Because they're opposites of each other. Okay. The last one that I want to do here is to design a general purpose tokenizer function. So what I mean by that is this function will take a string and return a tokenized version of it, a tokenized array of strings, tokenized along the given delimiter. So what I mean by that is, here's the example that I'll use. Here's my string, right? It's obviously CSV data. So for example, if I have a string that contains this data, it will give you an array containing the first one. Here, I'll do an array like this. Chris, then my last name, then the rest of this stuff. And I'll just go dot, dot, dot at that point, dot, dot, dot. And then finally, 103 Shore. There we go. So in other words, what we were doing before with string tokenization, but it's going to do it all in one function, right? And it's going to split it all up and give you that thing as an array. In fact, that's what they're usually called. It's called a split function, right? Here is your CSV data, say. Split, 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 split. Here's an array of all of those tokens with the delimiters removed. We good on understanding what we're trying to achieve? Okay. Then let's design the signature for this thing first of all. I'm going to call it split, right? It splits a string, split, right? It hashes it up basically, it cuts it up. What should my return type be here? If I'm going to give you an array of strings, how do we do an array of strings, do you think? Is that an array of strings? No, that's an array of characters. It's one string. If I want a matrix of integers, it's going to be int star star. So if I want a matrix of characters, or each row is a string, right? In other words, an array of strings, then I will have a char star star. Yeah?
So when we had two-dimensional arrays of integers, they were always, every single row of that matrix was the same length.
Mm-hmm.
When we're splitting up a set of data.
Yep, this one, the first one will be, in the example here, the first one will be 5, the second one will be 6, the third one will be 8, right?
So instead of having for like bookkeeping for array lengths, instead of being one variable we have to pass by reference or something, we have to pass by reference an array of lengths.
Do you have to? How do you know when the end, where there's the end of a string?
When you have multiple characters.
Exactly.
If you want to do bookkeeping, you have to use an array of lengths then, right?
If you want, no, because if I gave you the array of strings, and you wanted to know how many characters are in that first string, you have strlen, you can do it, right? But we do need something. How many tokens are in that example? 1, 2, 3, 4, 5, 6. I do need to tell you that, right? I need to tell you that I split this up into 6 tokens. So how are we going to do that? I'm going to go ahead and give you a string, and I'm going to make promises that I'm not going to change that string. That's why I made it const char star s, right? But what else do I need to tell you? The size of the resulting array. Remember, we did this before when we you did it in your labs too, right? We gave you an array of integers, and then we wanted you to give us a new array of integers, but only the even ones, or maybe only the positive ones, or something like that. I forget what we did. Get evens or get positives, right? And how did we communicate back to the calling function how big the resulting array was? With a pass by reference variable, right? I'm going to put into n the size of the resulting array that I give back to you. Now, as you observed, well, what about the size of each individual array? You have strlen that you can do that, right? Okay. All right. So the result or the size of the resulting array, the number of tokens is communicated in the pass by reference variable n. Okay? There we go. All right. Help me. Well, first of all, am I going to be making changes to that other value? Or to that string? Nope. So if I want to use tokenization, that strtoke, remember strtoke does make changes to the string. So how am I going to have to do it? I'm going to have to do it with a copy. So char star copy, I'll just call it C, is equal to char star malloc size of char times strlen of s plus 1. And here is where I would bring back that deep string copy that we originally made in the first string lecture, right? And not have to repeat this code over and over and over again. strcpy into cs. There we go. And now you can manipulate, we can manipulate c ... instead of the original s ... There we go. What do I need to do first, though? Let's create the result. Char star star result is equal to char star star malloc, and then ultimately I'm going to return the result. Remember that it's two-dimensional, So how many bytes do you want? How many rows do you want? How many strings do you want? Size of char star times how many? Do we know? Nope. So what do I need to do first? For the example, what do I need to do? Go through and count. Oh, there's 1 token. There's 2 tokens. There's 3 tokens. How do I know that? By counting up the number of delimiters. Which makes me realize that, did we ever give a delimiter? No. So we can always assume that it's going to be, we can say CSV split. And now we'll always assume that the delimiter is going to be a comma. Right? Is that as general as we can make it, though? No. Let's go ahead and make it into a general purpose where we've got char delimiter. There we go. And we'll just do 1 character delimiter, unlike strtoke that takes an array of delimiters. Or it takes a string of delimiters. Okay? All right, so let's go ahead and count up the number of delimiters, right, to know how many rows, strings you need. Dot, dot, dot. Right. So for int I equals 0, I is less than strlen of s, I plus plus, if s sub I is equal to my delimiter, and I do need to update that up here, char delimiter, there we go, then I will increment a counter. For this, I'll just go say int count is equal to 0, and then count plus plus. Hey, you know what? If I had taken my own advice and created that general purpose function of given a string, given a character, count up the number of number of instances of that character, then I could have saved here 5 lines of code, right? And use that in at least 2 functions right now. Anytime you find yourself using the same piece of code over and over and over again, even if just twice, it should probably be screaming out to you, put it into a function, right? All right, now I've got count. If I want to, I can refactor that now and say that that's the number of strings, or more accurately, it should be what? Num tokens. Num tokens and num tokens, right? Call things what they are. Otherwise, it's a count of the characters, a count of the delimiters. Well, yes, both, maybe, I don't know. But now that we called it num tokens, that's reminding me, is that equal to the number of delimiters? How many tokens did we say that there were here? 6. How many commas were there? 5, right? If you're splitting things up, then there are going to be 5 commas, and then 1, 2, 3, 4, 5, 6 actual tokens. So num token should be actually what? Here I am counting out the number of delimiters. So if I'm going to keep it as num token, if I want to, I should keep like num delimiters and then num tokens. And num tokens is equal to the number of delimiters plus 1. Or I can just go ahead and start it out at 1. Right? Now for those 5 commas that I count, right, that'll give me 6 because I started it out at 1. Yeah?
What about if there's a comma at the end of the list?
It's a good question. Do you want trailing empty tokens or not? That's a design decision, right? Some split functions don't do that. Some split functions do preserve them. Some split functions have yet another parameter where you say that you want a minimum or maximum number of tokens, right? So give me the first 5 tokens, and then make sure that everything is, just treat it as 1 token at the last or something, right? It all depends on how you design it, right? What are your design needs? Like, what do you need it for? In this case, I'm just going to end up doing CSV data, so I'm not going to worry about it, right? Besides, we're telling you how many tokens we ended up having, and if we don't include those trailing empty tokens, then we'll end up saying, that, well, if you expected 8, I only gave you 5, so infer from that what you want. Bad data, missing data, I don't know, right? That's up to you. Right? In this case, I think that we are going to end up preserving empty tokens at the end, right? But there you go. It all depends on how strToke actually behaves, because that's what I'm going to use. Right? We'll find out. It'll be a fun little adventure. Okay. All right, I've set up the array of pointers, but have I set up each row? Nope. So what do I need to do now? Char star token. And I've erased it all right now from before, but remember what we did on Monday? We tokenized this data. We used strToke. How do we call strToke? We provided 2 arguments. Do you remember what those are? The string you want to tokenize, and remember, I can't tokenize the original s. Why? Because we're going to be making changes to it, and I made it const. That's why I created a copy of it. We are going to tokenize the copy, right? And what are we going to tokenize it along? Well, commas, right, is what I want for this demonstration. But we made this general, and we want a delimiter here, okay? So there's our delimiter. Is this going to work? Let's find out. GCC, here, just GCC the entire thing. There we go. Where is it? There we go. It expected a const char star as a delimiter. Is that a const char star? Nope. It's a single character. It expects a string. How can we, quick and dirty here, how can we convert one character into a 2-character string, 1-character string with a null terminator character right after it? Char delim, right, of size 2. Right? And then we can say that delim of 0 is equal to the delimiter, and then delim of 1 is equal to the null terminating character. That's kind of cool, right? That's a static string, so it is allocated on the stack, right? But it's only 2 bytes, so who cares? We're not going to get ourselves into any trouble. Here's another way of writing it. Hopefully, if you remember how we created the primes array, what did that look like? There. How big is that array? Size 2, right? The first one is the delimiter, and the second one is a null terminating character. Right? We use that same syntax when we created an array of primes. Primes, and then the square brackets is equal to curly brackets 2, 5, 3, 5, et cetera, right? And I'll use this delimiter down here instead. There. And it compiles. It's just warning me about this unused data up here. Let me go ahead and get rid of that by going with the split function up here. No, I'll wait till the end to actually call it. All right, so there's my token, and now I can call. Now I've called strToke. That's the first time I've called it. Then I go into a while loop. While token is not equal to null. Oops. Null. There we go. I process that token. So 1. Process the current token, right? And then move to the next token. Okay? How do I move on to the next token? We'll do the easy one first. Another call to strToke, but what am I going to pass into strToke? Do I pass the same variable as before? Nope. Do we remember? If you want to continue tokenizing on the same string, what do we do? Null, right? Continue working on the same one that you were working on before. That's the signal there. And I do want to use the same delimiter here, so delim. There we go. What about processing the current token? Right? In this case, what I mean by processing is I'm going to copy, right, deep copy, in the current token into the ith row of result, right? Remember, it's an array of strings, so each row is one string. That means I'm going to have to establish an index variable, I. Started out at 0. Deep copy into the ith row. In other words, result sub I is going to be equal to token. Is that a deep copy? Yes? No? Am I going to run into any problems there? That's definitely not a deep copy. What's the other kind of copy? It's a shallow copy, right? So what do I want to do? How do I make a deep copy of a string? All right, good. A, allocate memory. B, doing strcpy, right? Exactly what we did up here to make a copy of the original string. And now I'm really wishing that I had that deep copy string function because I could use that again, right? And again and again and again. So let's go ahead and do it. I'll just go ahead and cut and paste here. That result sub I is going to be equal to a call to malloc size of char str len of not of s but of token, right? And then I will string copy into result sub I the token. Do I have to worry about null terminating characters here? No, strcpy takes care of it for me. Okay. Return the result. Let's see if it works. We need to call it first, of course. Come up here. There we go. Char star tokens. I'll pluralize it because it is going to be an array of tokens. And what do I call it? Split. I need to provide the data. The delimiter here is going to be a single character, comma character here. And then finally, I need to also have an n here for the number of variables, the number of tokens that I expect back. So int n, right? And then I can go for int I equals 0, I is less than n, I plus plus. Printf tokens of %d is equal to %s and the line, I and tokens of I. All right? Am I calling this function correctly? So data is indeed a character array. Delimiter, that is a single character. But what about this thing right here? Is n a pointer? Nope. That's a regular old variable. How do I translate that into a regular old variable? Ampersand. Okay. Let's see if all of the warnings have gone away. It's still not correct, by the way. Let's find out how it fails, though. There we go. Oh, killed. That was interesting. It looked to me like it was going into an infinite loop of some sort, right? And I don't know why it was ultimately killed. Let's ask valgrind. Valgrind, a.out. Result is number of students. You tell me, why did you kill it? It doesn't even tell me who killed it. There might have been a core dump or something like that. Problem with running valgrind is it's going to take like 10 times as long because it's simulating the program and watching everything. There we go. It killed. Oh, that's it? Line 11? No, it's not happening on line 11. I'm not sure what's going on there. But anyway, I think I know what the problem is. So let's walk through this again, walk through each step. We have a delimiter. We make a copy. We count up the number of tokens. We allocate memory for those tokens. Then we start tokenizing, okay? And we do tokenize, but what do we not do? I'm stuck in this while loop. How do I know that I'm stuck in this while loop? What other tool should I have run, maybe? With the G flag, gdb a.out. Run, and It seems to be stuck in a loop. Kill it, and then let's go ahead and look at the layout. Layout next, or layout source, let's say. Okay, next, next, next. There we go. Layout next. There we go. All right, that's kind of bad, but there we go. So I am indeed stuck in this while loop. I'll show you. Next, next, next. Stuck in this while loop, next, next, next. What is I at this point? Print I. I is still 0. So I is never incremented, but what else is never incremented? Print token. Print token. Right? I'm still at the first token. So quit. Right? Back to the drawing board here. What 2 things do I need to do to make sure that I get out of this while loop? I need to capture that token value first of all, and then set myself up for the next iteration. Am I always going to be copying it into 0, 0, 0, 0, 0, 0, 0? Nope. So I++. There's one more bug here. Let's see how it manifests itself though. Oops. GCC. Let's just run it. There we go. All right. So those all look good, except that we get to this last one and then eventually a segmentation fault. Okay. Up here, I'm running in the main. I'm running for as many tokens as you ended up giving me. Did we ever set that variable though in the function? Split. Do you see this variable anywhere being manipulated? Nope. So what should we have done? N is equal to num tokens. Is that the correct way of doing it though? N is a pointer. So how do we make a pointer variable into a regular old variable in order to set its value? Dereference it. Right. Now that should get the value 6. Let's find out. GCC. A.out. Excellent. All the bugs are gone, but might we have a memory leak here? Remember what I did up here? I created this copy so that I could tokenize the copy. What should I have done with it once I'm done? Make it go away. Free it. Right. Up here in the main, if you really want to be careful, you could go ahead and free the result here, free all these tokens, et cetera, et cetera. What would that look like? Free result for, and in fact, I'm just going to grab this here. For int I equals 0, I is less than n, I++, free result, or tokens, sub I. And then at the end, free the pointer array tokens. There we go. Make sure that I didn't break anything. Yay. Ask Valgrind. Am I leaking any memory at all? 0. Everything's taken care of. Questions? No? Okay. You'll have to do, bring all of these skills to bear that we've just covered, all in these string processing over in your lab and in your hack this Friday. Okay. All right. We have enough time, right? What time? Yeah, we go till 2:45. I won't go too long though. It seems like everybody's tired for. Was there something going on today? No. It's a Wednesday. We're college students. Go to bed earlier. Well, next week is our monthly run with CSE or with the School of Computing faculty. That's on Tuesday at UNL. Do we want to do one on Monday?
I'll do one.
Really?
Yeah.
A 5K or 10? Or do you want to go 10K?
I could probably do 10K, but I don't know if I'm in that good shape right now. But I would attempt 10K. Like
5K is 3.109 miles.
Yeah.
I could for sure do 5K, but I do 10K if you did it.
All right, we could do a 5K.
Okay.
Depends on the weather.
Well, it should be all right. The 60s or something. Yes? No? I don't know. Maybe afterwards on Monday, if you want to. I'll go ahead and bring my stuff.
I'll bring my stuff.
All right. You're not going to show up now. The what? Is it the 4th? 1, 2, 3, 4th, yeah. All right.
Absolutely no vision to
So 5K would be down to Baxter and then back here.
That's 5K.
Maybe it's a little bit less, but if you go all the way around Baxter, then that's probably 5K.
Okay.
So what?
It's a mile.
Well, right after this, 3 o'clock. Well, otherwise, if you want to come down to Lincoln on Tuesday morning at 9 o'clock, that's when we do it there.
You guys have, so that's some kind of run.
Yeah, we invite students. We only ever get like 2 or 3 students to show up. It's just me and Bonita, and then we run and we put it out on Twitter that, hey, we ran, yay. Right.
So is it just from here?
From here to the,
Faculty goes?
yeah, I don't know. You can ask Detloff to join us if you want. I'll ask Lim to join us if he wants to. All right. Well, just to introduce the next topic here, because the next topic is actually fairly easy. It's file I/O. We're not going to get into any of the nitty-gritty stuff with respect to like binary files, because if you're working with binary files, say like images, right? What did you do on hack 5 and 6 when you manipulated those images? Or what did we do for you? We brought in a library to do it, right? Images, media, all those kind of binary files, they have very specific formats that must be followed. Otherwise, they're going to be corrupted GIFs or corrupted PNGs or something like that. But what is a file? A file is a unit of stored memory. Usually we think of these things as things that are stored on disk, right? You've got a text file or you've got a source file or something like that. But what else is a file? Directories are files, right? Programs are files. Programs running in memory are files, right? Buffers, sockets. How does one computer talk to another computer over a network? It opens up a socket, and then it writes to that socket. That socket is a file. How does the computer on the other end receive that information? It's reading from that socket, which is a file. Right? In Unix, everything is a file. Right? A file is a file, directories are files, etc. They may be read, in which case you've got file input, or they may be written, in which case you've got file output. So file I/O, input, output. They may be binary, which is, again, pure data, or they may be plain ASCII text, and that's where we're going to focus most of our attention. Okay? Even plain text files can be structured, and I showed you examples of this already, didn't I? Of CSV data, XML versions of that CSV data, JSON versions of that data, or even base64 encoding of binary data. Right? So, I don't know, base64 encoder online. Let me go ahead and grab this source file that we were working with, and here, encode, right? Encode, there we go. That's what it looks like when you encode it as base64. Base 2 is binary, 0, 1. Base 10 is 0 through 9, decimal, right? Base 16 would be hexadecimal, 0 through 9, A through F. Base 64 has 64 characters. All uppercase characters, all lowercase characters, so A through Z, 26 of those, so 52. 0 through 9, that takes us up to 62. And then what are the other 2 characters that are used? I forget. I think it's underscore and ampersand. No, it might be equals here, but I think that's the trailing version, right? Base 64, Wikipedia. There we go. A through Z, there we go, 0 through 9 for the first 62. Where are the other 2? But differ in they differ, okay. It depends on the encoding system. It can actually differ. I thought it was always underscore and like equals or something like that, but don't quote me on that. Okay? Anyway, you usually do file I/O to support EDI, electronic data interchange. Programs are ephemeral. In other words, they're short-lived, right? You run a program and hopefully it executes in the blink of an eye and it's done. When you go from one run of a program to another run of the program, you need to preserve data. You need to what's called persist data. Persist is just a fancy word for saving data. Where do you save data? You save it to a file. Then, if you need to load up that data on another run of the program, you read in that file. The basic steps to working with files are three steps. You open the file, you process the file, and when we say process, you can do it for reading or writing. We'll keep it simple, doing one or the other. And then you finally close the file, okay? So the first step and the last step are the easiest. Opening a file, right? In C, a file is represented as a pointer, right? A file, all uppercase F-I-L-E, star, represented, right? Okay? To open a file, you use open. What do you think that stands for? File open, exactly, right? Now, why is it a pointer, right? So let's think about this as a file with a bunch of text, okay? When you open up that file, you need to know, well, what part of the data are you looking at in the file? Initially, what you need is a pointer. I'm pointing to the first character in the first line. As you read character by character by character or line by line by line, this pointer advances. You read one character and it goes on to the next character. You read another character and it goes on to the next character. That's why we use it as a pointer, file pointer. Sometimes they're called handles, a file handle, right? The fopen function takes two arguments. A string representing the file path, the path slash file name of the file you want to open, right? And a string representing the mode, right? So there are going to be two modes that we're going to focus on, lowercase w, right? Or R. So what are the three R's? We don't know what the three R's are? Reading, writing, and arithmetic? Uh-huh. So which one of these is the reading? Which one of these is the writing? Writing? In other words, if you're writing to a file, that's output. Right? If you are reading from a file, that is input. Right? So whatever mode you want here. Upon success, it returns a file pointer to the file, sometimes, again, referred to as a handle. Right? I don't know. Do you want this code or not? I'll go ahead and copy the demo into backup.c in case you want it, and I'll post it later. But otherwise, I'm going to go ahead and get rid of all this. We got 15 minutes, don't we?
Yes.
All right. I'll just show you how to open up a file first, all right? And then we'll end it, right? So file star F, or you can call it, sometimes people use H, why? Because again, it's short for handle, a file handle, right? H is equal to fopen. Give me a file to open. All right, test.txt, okay. And open it for reading, all right, fine. Do you see a test.txt file here at all?
Nope.
Nope. So yeah, go ahead.
So these file paths, they can be relative or absolute, right?
Yeah, we'll get to that in a second here, right? So what this does is opens test.txt, which is assumed to be in the current working directory, right? Or CWD. Right? So does that file exist? Do you see it? Do you see it there? Nope. So what do you think is going to happen in the event of a failure?
Will it create it?
If you're going to write it, yes.
I guess I'm trying to read
But you're trying to read it, right? So h is equal to null. It'll return null. Printf cannot open file. Does not exist. End the line. And let's see that working. gcc demo.c. Run that. Cannot open file. It doesn't exist. So let me create that file. What was it called? Test.txt. There we go. All right. and refresh this. Now you see that test.txt. Hello world, this is a file. 1, 2, 3, 4. There we go. 4 lines, various characters per line. Now let's run that again. And it will be successful and it won't print a message out. Right? Okay. More Etsy password. There we go. So there's this file on the system called Etsy password. What do you PASWD. PASSWT. WD. What do you think it stands for?
Password.
Password. That's the password file. Or at least it used to be a long, long time ago. What is the root password here? It's been redacted. Right? You can't see it. Right? In a different file, yes. In a file called Etsy shadow. Right? And I can't open that for good reason. Why? Passwords are there, hashed passwords. So even if I were to get this file, I would not be able to do anything with it because they'd be encrypted. Right? I can on VS Code because they haven't gotten rid of sudo access yet. If you're using CS50, that caused a huge problem last year when we used the CS50 IDE because they took away our damn sudo access. For anybody that doesn't know, sudo is super user do this thing, right? And so what am I doing? I'm listing the contents of that file. Now, it's still going to be not going to be readable here because it's encrypted and also it's in a different format, right? So if I did say file Etsy shadow, right? Or okay, I don't have that utility here. These are still not passwords here, right? At least not something that I can process directly, right? Okay, let's try to open up the Etsy password file for reading. That's also going to fail because I'm not doing sudo here, right? There we go. Oh, it is. Okay, that's probably because I already set the sudo once, and so it's going to be persistent for this entire. Oh no, that's password. You can do that because you can read the password file. You can't do the shadow file though. There we go. Duh. There we go. Cannot open file. Here it doesn't exist. That's the wrong message. What's the message I should be printing? Permission denied. You can't see that file. Yeah.
If you do sudo a.out, does it work at all? Like a permission?
Sudo a.out. Well, a.out. Yes.
Is there a way to have like a program that's edit text that doesn't have permission and then act on it like prompt user?
You could, yeah. Not within the program unless you launch another shell within the program. You'd have to run the program by itself as sudo or launch a sudo-enabled bash instance.
Or at least like tell the user, oh, this needs to be ran as sudo and it's not.
Yeah, that's what you generally do. Like if you ever do Python stuff, it tells you, like if you want to run apt-get or if you want to run pip or something like that to install something on the system, the instructions always say sudo pip install, sudo apt-get install.
Is there a way to, like, can the program detect if it's being run with that
I
privilege?
probably,
Can't you do,
I don't know, off the top of my head, I don't know how though.
if h equals null, you can't really tell what went wrong rather than something.
Well, you can by printing out the error number. Maybe. Printf %d error %d and the line error no. Then I need to bring in the error numbers. Remember these? Error
Is there
no.
a command in C that you can use to actually run shell commands?
Yes, system here sudo more Etsy shadow. All right. That'll be a system call. There, it's doing it. Except what was the error? Error number 13, right? Now let's change it so that it is foo.txt. Foo.txt does not exist. Let me get rid of that. And so remember it was 13 before. What is it now? 2, right? So whatever the error number 2 is, you could say that file does not exist. Whatever the error number 13 is, well, the permission denied. In fact, error no list .h. I'm pretty sure that we could actually look this up. No, you can't. Okay, fine. POSIX. Error no. error no ent. And then what is 13? Oh, there's no 13 here. I have no idea what this is. This is not POSIX.
Well, not if you hit F12 on it.
F12?
Well, take that, at least in the downloaded version of VS Code, if you hit F12, it'll take you there. If you click on the header file,
Whoa. Okay. Click on the header file.
or like highlight it, just double click. Yeah.
Wow. That's cool. Where's the include though?
Just
Features.
include some- there it is.
Go there. Okay. Find 13. Come on. All right, it's not there.
Mine says e-access is 13.
Yeah, these are 130s. It must be somewhere else. We're going down the rabbit hole here. I didn't mean to do this. There's an error types. Nope, that's not it either. Yeah, I don't want to go down the rabbit hole anymore. That's a cool feature though. I didn't know that VS Code will do that.
It'll do variables and function definitions as well.
Oh, okay. I don't want to jump into printf, but I'm sure that you could. Yeah, there it is. All right, that's what it looks like under the hood. Don't worry about it though. All right. All right. So cannot open a file. The takeaway here is that if you're going to open up a file and it fails for any reason, it will return null. You can check for that null and then quit. You can check for that null, reprompt, do whatever you're going to do. Right? You can have absolute file name, absolute paths. So for example, you could say h is equal to fopen of, like we did before, etc password. Right? You can do relative paths. So if I wanted to go up one level, that's going to be ... and then down one level into the data folder. And then within that data folder, I wanted test.txt. Right? So you can open up in the current working directory, you can open up an absolute file path. And we say absolute because the forward slash here starts you at the root file system and then goes down into the etc folder, and then it opens up this file within that folder. It's relative. You can go up one, down, then over, and then down, or something like that, whatever you want. Okay. All of those are options when you're using fopen. Reading, writing, of course, it depends on what you want to do. Right? Now to end it today, I'm going to skip to step 3. Right? Closing a file. Right? Once you are done with a file, clean it up. How do I clean it up? I close it. You should close it. Right? Using, what do you think? If it's fopen or fopen to open a file, it should be close to close a file. Right? Failure to close a file may lead to corruption. Right? The file could be corrupted. If you're putting stuff out to an output file and it hasn't flushed the buffer and the program quits or something like that, there's that 1% chance that buffer will not be flushed, that it'll corrupt the file, doing whatever you need, whatever, right? If you open it up, if you fail to close it, then it could lead to the lost data or something like that. Right? So let's do one last example here where I open up, what was that called? Test? What was in test? There we go. Hello world, this is a file. Right? I'm going to check to see that it's open, and then I'll go ahead and close it. Right? And close H. Come on. There we go. Run it. Right. Didn't change the file, did it? I opened it up, I didn't do anything, and then I closed it. Right? What if I opened it up and did one for say, writing, then closed it? Remember, here's the contents. Okay. What happened?
It went away.
It went away. Why? You opened it up for writing. You didn't write anything. Where was the pointer? At the very beginning. Right? You didn't write anything. You close it. Well, what did you write? That right there, nothing. Right? All the old data is gone. Right? There is no undo. There is no be careful. Do you really want to do this? Right? That data is gone. So, what would happen if I opened up demo.c, the very file that contains my source code here,
Nothing good.
and ran the program? Oh, come on. Go there, then over there. There we go. Right. So, I'll have to rewrite that demo when we come back. Yeah?
There's an append though too, right?
Yeah, there's an append. We're not going to cover that though. You can append. You'll still start at the beginning. There's also advance seek and then rewind, right? So if you don't want to touch, if I don't want to screw up this data, I want to just fast forward through the data, not mucking around with it, and then okay, now I'll start overwriting the data over here. Oh no, I need to rewind all the way to the beginning. Why do we call it seek and rewind? Have any of you ever owned a tape deck before? You've held one before, right? Well, you've got the same buttons, exact buttons on your MP3 players or whatever, right? You've got seek, forward, right? And you've got rewind. Why did we call it those things? Old tapes, right? How did you go? I skip this track, right? Fast forward, fast forward, fast forward, right? That was seeking through the tape, right? It was fast forwarding the actual physical tape. Rewinding was rewinding the tape in the opposite direction to go back, right? And everything was in terms of tape. Why? Think about the world in 1979, right? What was everything stored on? Tape, right? Tape backups. In fact, you can still buy tape backups, and even to this day, tape is still the cheapest per gigabyte of storage medium, right? You can buy tape backup at Newegg. Right? How much do they go for?
Giant tape backup drives to
Oh,
archives.
oh man. You can't buy tape backups apparently. You could buy those the racks apparently. No, that's a hard drive. I'm sure that you can still buy them because
I've seen them. I've seen new ones.
they still make them. Why? Because they are still the cheapest long-term storage that you can buy. Right? Hard drives have mechanical failure, and per gigabyte, they're still a fraction of the cost. Right? Trust me.
You want Newegg business.
Newegg business.
Newegg business.
I'm not even gonna bother going there.
Yep, they're all over here though.